Hello Gaians, this is Alvaro Mesa speaking, and today I will talk about my final project for the Gaia program, in which I develop different artificial intelligence algorithms for breast cancer detection. So, first of all, I will talk about me. I'm currently studying a master's in telecommunications engineering and working at Airbus operations as a data scientist. So my main tasks there are the development of artificial intelligence algorithms for aircraft predictive maintenance. So this is why I chose for this final project a topic related to the implementation of a artificial intelligence system for a real world case, that is breast cancer detection. So, breast cancer is, as stated here, is the top cancer in women worldwide and is increasingly, particularly in developed countries, where most cases are diagnosed in late stages. So the goal of this project would be to prevent those cases in order to take actions before we could not do anything for them. So over 508,000 women died in 2011, and survival rates vary greatly from 80% in North America and below 40% in poorer countries. So there are no a balance in those data. There's no a great balance. So the reason why this is a real problem and great problem is because of the lack of early detection programs, resulting in advanced cancer for most cases. So the solution would be the study of an artificial intelligence method in order to detect whether a woman is likely to suffer from breast cancer or not. So for doing so, here we present a typical machine learning pipeline. In our case, it would be for binary classification, whether an input person is likely to have cancer or not. So the first step would be the data pre-processing. So data from real world may be not in the real and correct format for the analysis. So we have to perform a pre-processing of there. And the next step would be the feature vectors creation, that is the input for machine learning models and contains the information whether a person had cancer with a logic 1 or not, with a logic 0. After that, the next step would be the model training and hyperparameter tuning. So it's training the algorithm for this certain task. And finally, we will evaluate the performance of the model based on different metrics. So we took a database from Kaggle community. It's a community which holds a lot of content, and it's a great community for data science, and it's real data from Wisconsin University. And here we can see that we have more cases of benign cancer than malign one, so it's almost the half. 359 records for benign ones represented in green, and 210 represent cancer in red, that is malignant cancer. So as for the visualization, we used the algorithm TSNAA in order to visualize the data. So here we can clearly see that there are two clusters. The blue points represent the malign examples and the orange one represent the benign examples. So basically an algorithm will take that input and that labels information and we'll try to make a frontier here. So for a given point, an unknown label, that is here, it will predict Benny, and for another point here it will predict Malik. So the results, we present them in a rock curve. It's a receiving operating characteristic that relates the false positive rate and the true positive rate. So here it's more we are close to this point, to the origin, this origin, more the algorithm is more accurate. So here it's 98% of accuracy. So we are almost perfect in the binary classification task. And we also present the confusion metrics. So we only miss 7 cases for both. The rows represent the ground truth, the real label, and the columns, the predicted labels. And this will be the true positives, the true negatives, excuse me, and this the true positives. So in order to assess an algorithm, this matrix is a proper way to see how is the misclassification. So finally we will end up with the conclusions. We use a random forest algorithm. We achieve a 98% of accuracy, that is higher than our expectations. So this algorithm, we will propose it as a real prototype in order to detect breast cancer, and we prove that using machine learning can solve real problems, because this is real data taken from Kaggle community. So I hope you enjoyed the presentation, and if you have any suggestions or doubts, don't hesitate to contact me in the community. Bye!